Hello there. In the last class, I had introduced to you about spherical mirrors. Two types of mirrors, concave and convex. And we had also learned some terms connected with these spherical mirrors. Okay, and it's very short, we will revise. We had learned about the principal axis. Before that, pole. Pole is the central part of the aperture. Aperture means from this opening to this opening. Okay, this is known as the aperture. The middle part of this aperture, or you can say the mid part of the mirror, is called pole. Somewhere here it is. And this is concave mirror. This is a part of the whole circle. Okay, that also I had drawn and shown you. And since it is a part of a circle, circle has a center. So this will also have a center. This is called center of curvature. And a line which connects the center of curvature and the pole, that line is called the principal axis. So till here we had learned in the previous class. Alright. Now today we will learn something called as focus of a mirror. And I am going to start with concave mirror. This is a concave mirror. So we will start with a concave mirror. Focus of a concave mirror. Now focus is a point which lies in between center of curvature and the pole. Okay, a point on the principal axis between the center of curvature and the pole is called focus. I have denoted it with capital F. Alright, now what is the significance of this focus? Let us understand. Now for this, we would need some parallel beam of light to be incident on this concave mirror. So I am going to draw the ray diagrams. You follow. So as you can see, I have drawn here 1, 2, 3, 4, 5, 6 rays which are incident parallelly on this concave mirror. So this is a mirror, it is going to reflect the parallel beam of light. So now after reflection, all these rays, they will pass or they will come towards the point which is called focus. So this is the significance of this point. Focus is that point. Now I am discussing about concave mirror. For a concave mirror, focus is that point where all parallel rays of light, after getting reflected from the concave mirror, they come and meet. All of them will meet at one point. That point is called the focus. Okay, this is in case of concave. Concave mirror. Now this is in case of the concave mirror. Now let us go and see what happens in case of a convex mirror. Now this is the case of a convex mirror. And for convex mirror also, these are the terms that we had studied in the earlier class. The center part of the mirror is called the pole. This is the aperture. From this opening to this opening, the length is called the aperture. This is the center of curvature. Now this mirror is curved this way. Okay, if I complete the circle, then I would get circle maybe like this. And just a rough diagram to make you understand. So this is just a part of the entire circle, and this will be the center of that particular circle. So the center of this whole circle, of which this mirror is just a part, that center is called center of curvature. And by definition, so this is the line connecting pole and center of curvature. This is called principal axis. Okay, coming back to focus. By definition, focus lies in between pole and center of curvature. Okay, position of focus should be where? Between pole and center of curvature. Now let us see where the focus, where does the incident parallel beam of light meet in case of a convex mirror? Do they actually meet or not? Let us see that. So I am going to draw a few rays of light parallel to each other. So this is one ray of light. This is another ray of light. The arrows show the direction from where to where the light is traveling. That's very important. Giving arrows. You have to excuse me about the lines. They may not be as straight because I am not using a scale, as it is obvious. Okay. These are the incident parallel beam of light. Now this is a mirror. This side is silver, this side is the reflecting surface. Obviously these rays will not penetrate and go on the other side. No, they won't. So now what will happen to these rays? They will get reflected back. Now is there any chance that after reflection, like in case of concave mirror, you see the diagram over there. In case of a concave mirror, the rays of light after reflection, they actually met each other at focus. But let us see now, in case of a convex mirror, is it possible to make the reflected rays meet? So following laws of reflection, they will all reflect. So as you can see over here, these rays, like this ray comes here, it reflects. This ray comes here, it reflects. This ray comes here, it reflects. Here also, this particular ray, it reflects. Now you might ask me, sir, what are these lines? These lines are the direction in which the light has reflected. Like this ray reflected this way. So I have pulled the ray backwards straight. It may not appear to be straight. You can look. Better diagram is there in the book for you to understand. But to make you understand, I have drawn a rough diagram here. So, as you can see, all these reflected rays, they are scattered here and there. In other words, they don't meet each other. So, we are drawing a ray diagram. We need the position of focus. So, in order to get the position of focus, we have to prolong these reflected rays backwards. So, if you prolong them backward by drawing straight lines, you will see that they all meet at one point. And that point, this is not the point where the rays of light actually meet. No, it seems to meet when you draw a ray diagram. So that point where the rays of light after reflection in a convex mirror seem to meet each other, that point is called the focus of a convex mirror. I will show you where this diagram is. Page number 60 of your book. Here it is. This is for concave mirror that I have drawn there, and this is just now that the diagram that I have drawn. You can see over here the lines are straight. Here are the incident rays. For example, this particular ray, incident, it gets reflected. If you prolong them backward, it comes and meets over here. Same with this second ray. It comes here, gets reflected. But when you prolong them, it meets here. So like that for this and this ray also they have done. This ray gets reflected. If you prolong this ray backward, this ray gets reflected. If you prolong it backward, all these rays that you are prolonging backward come and meet at focus. Okay, so this focus is the point in a convex mirror where the rays of light seem to meet each other. Okay. All these rays of light after reflection from the mirror seem to meet each other. That point is called the focus in case of a convex mirror. So I hope now it is clear to you this term focus. Okay, focus of a concave mirror and convex mirror. Now next term that is there is focal length. Focal length is the distance from pole to focus. Okay, from pole of the mirror till the point where the focus is, that distance is called focal length. Okay, I will draw it somewhere here maybe. Okay, here is the point where the pole is. I could not draw here because it will get scribbled. It will look like a scribbled line. So see, this is the pole and here is the focus. That distance is called focal length. This is in case of a convex mirror. In case of a concave mirror, from focus till pole, okay, from focus till pole, say the focus over here, it is from here till say here, this is the focal length. Okay, from the focus till the pole, I have drawn the line here to explain. This length is called the focal length. There are some rules for both concave and convex mirrors. Okay, rules of reflection that they follow. Now, few rules which are important we are going to discuss over here. So, rules of reflection in case of a curved mirror. There are two types of curved mirrors. No? So, the first one that we are going to discuss is for concave mirror. Now, the first rule in concave mirror is when a ray of light is incident means coming towards the mirror, when it hits the mirror and reflects, then the reflected ray passes through the focus. This is the rule number 1. Okay. The that's what I have written here. The diagram is clear to you, the rule will be very clear to you. The arrows are very important here. It shows over here that it is coming towards the mirror. The incident ray, this is the incident ray coming towards the mirror. Any ray which comes towards the mirror is called incident ray. After it gets reflected, it passes through focus. When the ray is, the incident ray is parallel to the principal axis. This is the principal axis. Okay, it passes through center of curvature. That is the principal axis. So any ray of light is parallel to the principal axis. After reflection will pass to the focus. This is rule number 1. Now the second rule is for concave mirror. The second rule is, let me show you from the diagram. It is the opposite of the first rule. Now here, when a ray of light passes through the focus and hits the mirror, see the arrow diagram has now reversed, changed. The diagram remains same, only the arrow position have reversed. Now it shows that this is the incident ray. It is passing through focus, hits the mirror, and after reflection, what happens to it? It now becomes parallel to principal axis. If you observe carefully, this is the opposite of the first rule and the first diagram that we had drawn. Okay, in the first diagram, incident ray was parallelly coming towards the mirror, parallel to principal axis, and after reflection, the reflected ray passed through focus. But now, in this rule, second rule, the incident ray passes through focus, hits the mirror, and after reflection becomes parallel to the principal axis. Okay, so this is the second rule. Okay, now the third rule for concave mirror, rule of reflection, is any ray of light coming from the center of curvature. Observe this ray of light, this incident ray of light is coming from where? From the center of curvature, and then it is going and hitting the mirror. This arrow indicates, okay, this is the incident ray. The incident ray is coming from where? The center of curvature. Then in which direction will be the reflected ray? Let us read. After reflecting from the mirror, it goes back in the same line. Now what does it mean? So this is our incident ray. It comes from where? From the center of curvature. After reflecting, it will go back in the same line. That means the reflected ray incident ray after hitting will reflect back and follow the same path of the incident ray and go back where? Towards the center of curvature. So the reflected ray again will go back towards the center of curvature from where the incident ray of light had come. Okay, now the fourth law for concave mirror, law of reflection. If any incident ray comes and hits the pole, then what will happen? Here, let's read. If any ray of light is incident on the pole of the concave mirror, then how will it reflect? It will reflect back by obeying the laws of reflection. Do you remember from class 7 the laws of reflection? Incident ray, reflected ray, and the normal lie on the same plane. That is rule number 1 for law of reflection. And the second law of reflection is angle of incident. Now here in this case, this principal axis serves as the normal for this particular ray. Okay, normal for this particular ray. So this will become the angle of incidence and this will become the angle of reflection. This is the angle of incidence. Remember what is angle of incidence? Angle with the incident ray which meets with the normal, and the angle which the reflected ray meets with the normal, that is called angle of reflection. So these are the two laws of reflection. Incident ray, reflected ray, and the normal, they lie on the same plane, and angle of incidence is equals to angle of reflection. So any ray of light which falls on pole will reflect back obeying the laws of reflection. So how will it reflect? While drawing the ray diagram, you have to be careful that this angle and the angle which the reflected ray makes with the normal should be equal to each other. So I have shown these two angles should be equal to each other. So on pole, if any incident ray falls, then it will reflect back obeying the laws of reflection. Okay, now the rules we will learn for the second type of curved mirror, that is for convex mirror. Now for convex mirror, as you can see here, the bulging side is the reflecting surface and the hollow side is silvered. So this zebra crossing like structure that I have drawn symbolizes the silvering of mirror, painting of mirror. So the right side is silver, so the left side is the reflecting surface. Now as you can see, this is the principal axis, the central pole, the center part of the mirror of which this mirror is a part, the center of the circle of which the mirror is a part, pole and center of curvature connected with principal axis, and this is focus. Remember, focus lies in the middle of pole and center of curvature. Now let's see the rule. Now this first rule says that if any ray of light is incident parallel to the principal axis, if incident ray is parallel to the principal axis, then the reflected ray will be in such a way that it will seem to come from where? Focus. Okay? The reflected ray will be in such a way that it will seem to come from where? The focus, as if it is originating from the focus. So this dotted line symbolizes the direction of this reflected ray. Okay? So the reflected ray will seem as if it is coming from where? Focus. This is in case of a convex mirror where the incident ray is parallel to the principal axis. The reflected ray will be in such a way as if it is coming from the focus. Now where is this focus? Our reflecting surface is on the left side. So focus is right on the opposite, the right side. That's why it is written over here that it will see, the reflected ray will seem to come from the focus. Where is the focus? On the other side of the mirror. Okay, reflecting surface is on the left side, focus is on the right side. Okay, now the second rule for convex mirror is the opposite of the first rule. Okay, now this second rule, let me explain through the diagram given over here. This is the convex mirror, principal axis. Now, the position of the arrows have reversed. If you have seen the first diagram, in the second diagram, the position of arrows have reversed now. Now, the incident ray, this is the incident ray, it is going in the direction of focus. Now, this focus is on the other side of the mirror. Okay, for a convex mirror, the focus is actually on the opposite side of the reflecting surface. The reflecting surface, if it is this side, the focus of this convex mirror will be on the other side, behind the mirror. So, incident ray is going towards the focus. Then what direction will be the reflected ray? The reflected ray will become parallel to the principal axis. Okay? It will not penetrate. It's a mirror, remember. Mirror cannot have any ray penetrating itself. So ray will not penetrate. So this dotted line is actually the direction of this incident ray, showing the direction, and where the direction is, it leads towards the focus. For that reason, this dotted line have been shown. This is not the actual direction of light. The actual direction of light is this. The incident ray, after hitting the mirror, it becomes parallel to the principal axis. So it is the opposite case of the first rule in case of convex mirror. Okay? In the first rule what we had learned, if any ray of light comes incident to the principal axis, after reflecting after reflecting it goes in such a direction as if it seems to come from focus. That was rule number 1. But this is rule number 2. Here, if any ray of light appearing to be coming towards the direction of focus, then it will stop right over here. After reflecting, it will become parallel to the principal axis. It won't go on the other side. So this dotted line is actually the direction, showing us the direction of the incident ray that it leads towards focus. any ray of light leading towards focus will become parallel to the principal axis. The third rule in case of convex mirror is, now the incident ray will be in the direction of the center of curvature. If there is any incident ray which comes in the direction of the center of curvature, then the reflected ray will go back in the same line. Now if you recall, for concave mirror also we had one such case wherein a ray of light was coming towards the center of curvature. Then what happened to it? The reflected ray went back in the same line. So also in this case, the reflected ray will go back in the same line as the incident ray. That means the incident ray and the reflected ray will be in the same line. Okay, the incident ray will stop right here. Don't think it is going to penetrate through here. These dotted lines that I have given here, it symbolizes the direction of light. This incident ray of light is going towards the center of curvature. This dotted ray is actually given to show us the direction of the incident ray. So the incident ray is that it's going to come till here and stop, reflect back and go back in the same direction from where it came. So incident ray and the reflected ray will be in the same line. Okay, the last law for convex mirror. If any ray comes towards the pole, hits the pole, then in which direction will the reflected ray be? Now this was a case in concave mirror also, if you remember. In that also we had an incident ray coming and hitting the pole. So which direction would be the reflected ray? The reflected ray would be in the same direction as obeying the laws of reflection. So same case for convex mirror also. The direction of the reflected ray will be determined by determining the laws of reflection. How? You have to calculate the angle of incidence. This is the incident ray. Whatever the angle of incidence will be, the reflected ray will also have the same angle. In other words, the angle of incidence and the angle of reflection will be the same if the ray of light hits the pole of the mirror. Okay. So you have to remember these 4 rules for both concave mirror and convex mirror. 4 rules I have given you in the notes in the video itself. Take time and write down these rules in your copy. 4 rules for concave mirror, 4 rules for convex mirror, along with the diagrams that I have drawn for each rule. They will be required when we draw the ray diagrams. This chapter has a lot of ray diagrams in it, okay? So, in order to draw these ray diagrams, these rules you have to keep in mind. So, unless you know these rules, you will not be able to draw a single ray diagram. So take time, go through the video and please note down the rules. Pause the video for each rule, write down the rules in your copy. I am telling you these rules will be coming in your exam also. I am going to ask you the 4 rules in case of a concave mirror, 4 rules in case of a convex mirror. So you will require it not only for drawing ray diagrams but also it is going to come in your exam.